So instead of going in a straight direction, it has to move away from it. So this is going to be your emergent ray. Did you understand? Yes.
How much do you would like go in like upward direction factor?
No, you just think about it. It has come to this point. How will it go up from a denser medium to a rarer medium? It has to move away from the normal. See now, it will not go in this direction. It has to move from the normal. This dotted line is your normal. Once again, it is going to be n dash or whatever it is, or you can even say m dash. It is moving away from the normal. Did you understand, Kaushik? It will definitely not go above. Why does it happen like this? Is you will notice here that these two surfaces, AB and CD, are parallel to each other. Okay? But whereas in a glass prism, the two surfaces where the diffraction is taking place, that is not parallel to each other. Okay? And that's the reason you will find that it is bending towards the base. Have you followed? Is that okay? Now that is an experiment. That is basically what I'm going to be showing you. Hope it has moved. Okay. Before I show you that experiment actually how it is going to happen or what is going to happen, we can perform this experiment in the lab. How do we do? We are just going to take a paper, keep the prism, we are going to draw the outline, right? And we are going to take two pins. Two pins is what? Those paper pins. And we are going to select a particular angle. Where is the angle of incidence? Is it this angle or is it this angle?
Between the normal and the
Yes, always between the normal and the incident ray. So this happens to be your angle of incidence. Suppose I say I want to take it at 45 degrees. Okay, so I draw that line 45 degrees and I'm going to put two pins onto the paper. Right? What does that show? That is going to show my incident ray. Now I'm going to come on the other side of the prism and look from here and close one eye so that there's no refractive error. And I'm going to fix two more pins such that it appears to be in a straight line. Is that okay? Now I have fixed these two pins. I'm going to remove the prism and I'm going to join this line. I'm going to join this line and then this line. Okay, so that is the experiment that we are going to see here. What can we find? That your angle of incidence is also equal to the angle of emergence. Okay, so angle of incidence and angle of emergence. Obviously, it shows that there has been a deviation. So I'm going to use my black pen to show you that there has been a deviation. See this. This was the original path of the incident ray. Are you able to understand what I'm saying? Now what has happened? It has taken a turn. There has been a deviation and that ray is coming down here. So if I extend this ray behind, this is the angle of deviation. Do you understand? Is it clear? Okay. See once again. This is my original incident ray. Okay, this incident ray has deviated and it is coming out in this plane, okay, in this direction. So if you are extending your emergent ray behind, okay, you find that there has been a deviation from the original position. And that happens to be your delta D or angle of deviation. Is that okay? Right? Let's see this. Do you see how the prism actually looks like? That's your 3D. Okay. So now you're going to take a drawing board and you're going to fix the prism. Do you understand why we are getting that triangular shape? You're drawing the base. Now you select any angle. First of all, you have to draw that normal. So what is that line? 90 degrees. It shows that they are drawing the normal. Will you be going to the lab to do any of the experiments?
Yes.
Yeah? Definitely this. Yeah.
Well, we do the same thing for the glass lab.
Yeah.
The group is-
Yes, yes. Same thing. Did you see? Okay, so that's your normal. You can write it as what it is, AB or A or whatever it is.
From where in that
We can take any angle. Now in this particular case, maybe you can choose an angle of 30, you can do for angle 40. In the lab, we can perform for 2, 3 different angles and we can compare angle A and angle E. So now he has taken an angle, maybe it which looks like probably 30. Once again, we are going to put back the prism, fix those 2 pins. Let me just go back. Yeah, see those 2 pins. You're going to fix those 2 pins. So the 2 pins will actually show you the incident part. Now you have come to the other side of the prism. Did you see that? And we are going to fix 2 more pins in such a way that it appears to be the same path. There is always going to be a refractive error if both your eyes are open. Have you been watching Olympics? Why do they call rifle shooting or something of that? So they cover one eye. Did you notice that?
Yes.
So that there is no refractive error. So you close one eye. Same thing here. You close one eye and then you use the other eye. Okay, so you will fix 2 more pins in such a way that it appears to be in a straight line. So that's how it actually looks. Now let us see what is happening. We are going to take out the prism and you see that the path is bent. Did you get it?
Yes.
So now we are going to join those 2 dots. Because the angle here is small, and then of course you are going to join that. So this is your incident ray. The one which is inside the prism will be refracted ray and this will be remote. Now you are extending that line behind. Did you see this line? You have extended that line and that will show you the angle of deviation. This is your angle of deviation. Correct? That's it. And the rest of it in the experiment is how we find out the refractive index. That's not for us, that is for the 11th and the 12th. Yeah, I'll show you. See, angle of deviation they are calculating. You are increasing the angle of incidence 30 degrees, 40 degrees, and all that, and see that angle of deviation. There's something called as an angle of minimum deviation. That's not there for us. See, on another plot, it keeps on decreasing. You get a typical U-shaped graph as the angle of incidence. Yeah.
Physics is very
No, not very. Once you understand anything, for example, 10th standard, for a pen it was difficult, but do you find it, are you finding it now?
It's easier than this. Gravitation.
Okay, right. We'll read that and we'll come back to your doubts, whatever you have. Refraction of light through a prism. Very shakily. You have any textbook today? No? None of you have? Both of you don't have? Who has on this side? Yeah, Alia, or Lee, Humera, Lee, anybody?
I have
Lee, you will read.
diffraction of light through a prism.
Okay, at least you have those books to see that.
You have learned how
What?
Matter.
So anyway, she's reading now, you better pay attention. Read, Ruchi.
You have learned how light gets refracted through a rectangular glass lamp or parallel refracting surfaces. As in a glass lamp, the emergent ray is parallel to the incident ray.
Underline the
However,
statement. Why is it parallel in the first case? Because the two refracting surfaces are parallel to each other. Okay? This can be asked as a question.
However, it is slightly displaced laterally. How will light get reflected through it through a transparent prism? Consider a triangular glass prism. It has two triangular bases and three rectangular lateral surfaces. These surfaces are inclined to each other. The angle between its two lateral faces is called the angle of the prism.
Now, where is this angle of the prism? Angle A, here. This is your angle of the prism. Did you see that? Underline the word angle of the prism. So, angle A here will definitely be your angle of the prism. Sometimes it can be an equilateral prism, where you have got all of them as equal.
Let us now do an activity to study the refraction of light through a triangular glass prism.
Okay. Now, there is this diagram. I want you to observe. I think it's there in that book also. So observe this diagram carefully, because now when you're talking about AE is the incident ray, I want you to see correspondingly what it says in the figure. Okay. Here PE is the incident ray. Did you notice which is the incident ray? Yeah. PE. Right up to the glass slab. Okay. Then EF is the refracted ray. Did you get your EF?
Yes.
It has to be inside the prism.
Yes.
Refracted ray is inside the prism. Okay. And then Fs is the emergent ray. So it is emerging out. You may know that the ray of light is entering from air to glass in the first surface AB. So how is it? From a rarer medium to a denser medium. Therefore, it is moving towards a normal. The light ray on refraction is bent towards normal. In the second surface AC, what is happening? Denser medium to a rarer medium, and therefore it is bending away from the normal. Okay, hence it has bent away. Compare the angle of incidence and the angle of refraction. Is it similar to the kind of bending that occurs in a glass slab? If you look here, what will be the refractive angle of refraction? Will it be more or will it be less than the angle of incidence? How did the ray move? Did it move towards the normal or away from the normal? It is towards normal. So what will be the angle of refraction? It will be less, obviously. So here, angle of refraction is going to be less. This particular shape of the prism makes the emergent ray bend at an angle to the direction of the incident ray. Okay, it happens because of the shape. This angle is called as the angle of deviation. Underline that. Angle of deviation. In this case, angle D is the angle of deviation. Did you notice where angle D is? Okay. Most of the textbooks, they will give you a D like this. Boys, don't talk. Don't talk. Okay. Angle D. Now here they have given us a capital D. This will be usually given as a delta D. Mark the angle of deviation in the above activity and measure. Yes. So I will not be taking anything more because then will get a whole lot of questions. I thought I didn't know about these children being absent today. I thought I'll be able to finish a good part of the lesson.
Even biology ma'am on Monday to for that they should have participated.
Yeah, because I've kept it up to repeat the whole thing. No? Chalo, kya hai? What was your doubt? Acid basis of your doubt.
Yes, no, the plastic elements
Now can you just like tell us that what is the
See, the first part of the lesson,
Page number 30.
yeah,
हाँ तो आ रहा है
you don't have the full
chapter.
We have 80 marks exam.
हाँ, मेरा सामने आ रहा है जिंदगी में
मेरी माँ हमारा मोनिका हमने बोला CST UCC है
Yes.
what do you have in your school?
Ma'am, 2 chapters of chemistry, 2 chapters of physics, and 2 chapters of
80 marks chapter ना मामा
हाँ वही तो
20 marks है चलो.
मामा we have it every month
every month, yes.
and like
20 marks.
दो महीने के बाद हम 80 marks का पेपर
ठीक है ना, ultimately it is coming to the same, whatever the school does. Okay, चलो.
Ultimately,
It's something you have to, anyway for the board examination, you will have to sit for the 80 mark. And here in UT also, we will be giving you mock exams, starting from December onwards. November, December, so definitely yes. And we will be very comfortable with our portion. We will also have time to go through some of the chapters. So the first part, Kaushik, since you are asking me, basically talking about different type of indicators, olfactory indicators, okay, what is universal indicator, what is the change of the pH, etc., etc. Okay.
Reactions of oxides with metals.
Then the second part of it is acids and how they react with metals.
some what are the like main like equation or formula
Whatever equations, everything, whatever is there. You
There
can't go wrong with that.
there used to be one particular example 100 for each and every topic, like metal carbonates with metal hydros, carbonates.
Hydrogen
Yeah.
carbonates, yeah.
Carbonate
Carbonate,
various exam then
carbonate or hydrogen carbonates always gives carbon dioxide. It's always a gas which is released is going to be carbon dioxide. Really?
only in the previous exam there was a like equation for PV का lead ना
Lead nitrate.
lead तो उसमें था and उसमें
I also had
I lost marks in that and
Not even I lost marks, and it was in the activity. Sir, this
ma'am our teacher told that activity won't come
So,
Every activity I am
every
talking to
activity
you.
would come, ma'am.
ma'am our teacher said that no
No activity would come. Even my teacher said.
Didn't I tell you?
I
Every
actually studied
diagram,
that activity.
yes, every diagram that I am discussing, every diagram, every experiment I am doing. Because many of the questions are based on you know what, boys? Sometimes the questions are a student is performing experiment. You know,
Ma'am,
based
but
on
in
the
that,
diagrams.
in that reaction is necessary to write precipitation reaction.
ma'am
Because,
especially in case
Yes, there is a question.
because I just wrote double displacement and ma'am was like, no,
Did you write a color also?
yellow color precipitate was
You have
formed.
written that.
I wrote but
Have you used the word yellow color?
हमारे
Precipitate.
precipitation precipitate
Precipitate, if you have used then she wanted the word
precipitation
precipitation.
reaction. She also wanted that. She was like, no, you have
If you have
written.
written precipitate, that itself.
Because the question itself had that the yellow color precipitate was formed.
हाँ
and you have to name it.
same question था क्या
So I just wrote double displacement reaction.
Then the next part of it is reaction of metallic oxides with acids. So what are we trying to understand? Metallic oxides and base, non-metallic oxides. Non-metallic oxides are acidic in nature. Like for example, sulfur dioxide, carbon dioxide, they are non-metallic
always
oxides. You think now. What is a metal oxide and what is a non-metal oxide? आपका हो गया for example non-metal.
no, metals are usually basic.
ma'am so non-metal oxides are acidic
No, metals are usually basic in nature.
Metal no, don't talk about a metal. We are talking about a metal oxide.
Yes, metal oxides.
एक minute. Suppose I am taking magnesium as a metal. ठीक है? Metal oxide क्या होगा? Magnesium oxide. Magnesium oxide is basic. Suppose you take sulfur. Sulfur is a non-metal. Okay? And you take an oxide of this, it will be sulfur dioxide. This is going to be acidic in nature. Do you understand? Don't say metal is basic or metal is oxide. They are talking about an oxide. Understand? See, for example, carbon. Carbon is a non-metal. Oxide of carbon क्या होगा? Carbon dioxide. ठीक है? Carbon dioxide is acidic. This will dissolve in water to give you carbonic acid. This will dissolve in water to give you what acid?
sulfuric acid
Do you understand? Yes. So how do acids and that part of it you should be clear. Then how do acids and bases react with each other? वो क्या reaction होगा? Yes. What happens in neutralization?
Salt and
Salt
water.
and water.
They may give you different acids, they may give you different bases. They're based on the supermine. Then, why does an acid behave like an acid?
क्या?
Yeah.
क्यों?
Why does an acid behave like an acid?
Because
Because
it's
it is
acid.
Because it has
The
acid.
pH and the
H plus
concentration of
ions.
hydrogen ions
H
in
plus
the acids are
ions.
H plus.
H plus ions.
So whether you talk about
H plus
HCl
acid, OH was the base.
or you're talking about H2SO4, H अगर होगा, that means it's capable of giving out an H. Okay, so that is why it is acid. Why is it a base? Anything? Why is it
OH minus
concentration.
sodium hydroxide, magnesium hydroxide.
So if there is a question that like for example
So H plus, anything that has a H plus
base
is an acid. And
and
an
OH
OH
minus. Why is it?
Yeah, tell me
Like
first.
OH concentration ज़्यादा
I'm
होता है.
like, for example, there is a question that bases also have OH in it, hydrogen, but then why are they
OH concentration is more, right?
H plus, he's saying that bases may also have H plus ions, but
Yes, concentration.
But then OH concentration will be very low.
so it will be dominant.
Okay. Then similarly, litmus paper, why does it change only in the presence of water?
Because hydrogen cannot
near
remain
zero
single.
level to acidic, near 7 level as
Neutral.
Because of,
like 7
separating sign.
Basic.
Hydrogen.
Hydrogen H plus cannot exist as
A
such.
single atom.
Yes.
It has to combine with a molecule of water.
Hydronium ion.
Hydronium.
H plus
H3O
and
plus.
plus H2O will give you
H3O plus.
H3O plus.
is
Hydrogen.
this given?
क्या है that is giving you the pH?
Like
Approximately you should know, you don't have to by heart those values.
I'm for like 20 marks it won't come.
Why not?
pH is near.
No, I'm telling you. Suppose they're asking you for an MCQ. Suppose they tell you something else. Identify the pH of, let us say, gastric juice, and they will give you four options. You should at least know now that it is acidic, which is acidic. For example, toothpaste or shampoo or whatever.
Gastric
it is.
juice is acidic.
Answer toothpaste shampoos are basic.
Toothpaste, shampoo, detergents, all of them
I
are
asked my
basic.
teacher, she said, like, you don't have to bias the pH.
You don't have to. At least you should know that which is acidic.
Which is acidic, which is basic.
Acha, tell me about rainwater.
Neutral.
Acidic.
Acidic,
Acidic.
Acidic. Because of the pollution present in the air.
Sulfates and
Okay, basically it is nothing but just sulfur dioxide, which I told you, sulfur dioxide, carbon dioxide, which is present in the atmosphere. That becomes to constant.
Dissolved in the rain.
Monuments
Dissolved
like
in the
Taj Mahal,
rain.
yes. Any monument which is made up of marble, which I consider.
That's why I think the government is
But I heard like they're quite fake.
That was 8 marks.
They're coloring it white.
Not why I mean, no, Multani matti,
Oh,
yeah, just as you have
So
your face.
volcanic activity is basic now.
Yeah, because there is a some plant which is actually producing sulfur, fumes of sulfur at Mathura. So that I believe is affecting the Taj Mahal. So that is how they have stopped the manufacturing of the petroleum plant or something. And in order to keep the marble pure white, they are giving a treatment.
it's Multani matti is
Yeah.
that's why it will
Yeah,
neutralize.
yeah. Okay. Then these type of questions on the next page.
Ma'am, explain this.
Yeah.
The first chapter.
Yeah.
Diffraction.
Easy to how you can explain, but in my exam also it is not.
Diffraction में आता है.
Right.
Fraction आ रहा है
अच्छा ये वाला what?
Now for
Why is
chemistry,
it antacid? Why do you use an antacid?
Neutralize
Such type of
acid.
questions.
to neutralize bases. नहीं sorry neutralize the acid use.
and chemistry, biology, physics.
Chemistry I will give
Very
about
clear.
Okay, the next one that you were asking about this.
yes.
So you can.
Pure alkali process.
अरे वही देखा.
Mom, can you explain this?
NaOH aqueous is brine solution.
What is brine? Brine is nothing but concentrated
Concentrated
sodium.
Sodium.
Hydroxide.
Right.
Seawater. What is seawater?
Brine.
Concentrated NaO, NaCl.
NaCl.
Brine is sodium chloride, sea water. Because what are we taking here? We are taking sea water. Brine is nothing but see the first paragraph. When electricity is passed through aqueous solution of sodium chloride. First line there. Kaushik, what is brine?
Concentrated NaCl.
That means you're basically taking seawater, concentrated seawater, and we're getting important chemicals. So what are the important chemicals here? What are the two gases? What are the two gases that you get?
Chlorine and
Chlorine and hydrogen. Okay, and what is the solution that you're getting? Sodium hydroxide. That's why it is called as a chlor-alkali process. Alkali में क्या हुआ? Sodium hydroxide. Is the alkali. It chlor is for chlorine. And of course hydrogen.
Alkalis are the bases dissolved in water, right?
So what is an alkali? Here now, I'm talking about the word chlor-alkali cube there.
No, but I wanted to ask.
Sodium hydroxide. Okay, sodium hydroxide.
Alkali.
What is soluble? Any base which is soluble in water is an alkali.
So these
That's why group number 1 is called alkali group. Okay, what happened, Kaushik? You said explain and you're busy talking.
No, ma'am, we are like,
You want to listen to each other.
ma'am, he is
Okay,
telling
you
that.
I'm asking you questions now. Now there are two electrodes there. Did you see the diagram?
Yes.
Okay, one is a cathode and one is an anode. Okay, so which is an anode and which is the cathode?
Anode is
Cl.
Cl2 and
Chlorine is coming to the
Positive.
positive
Anode.
anode. It is the anode. Okay, and you have got hydrogen coming to the
Positive.
Negative.
cathode. And where is sodium hydroxide connected?
The on the surface.
Cathode.
Not
Near the
coming.
cathode.
Okay.
Near the
But still
cathode.
listen, keep listening.
Near the cathode.
Yeah, it basically begins to settle down. Okay, and you have got three uses for each of these three things.
ma'am, can you explain one thing that sodium hydroxide? You
Yeah.
said that very good.
You were busy talking to him.
No, no,
I understood, ma'am, I understood.
Okay, now you tell. You
Ah,
explain to your friend.
Like, okay.
Go on.
Yeah.
Brian, you explain to the whole class now. Come on. What is Brian?
Brine is the concentrated NaCl.
Okay. Now what is the cathode?
We were fighting on that only. I said it first, but he said it is wrong.
You are taking ordinary sea water, concentrating it, and therefore you are getting useful substances. What are the three substances that you are getting?
Hydrogen,
Hydrogen.
chlorine, and NaOH.
Yes.
Of
Sodium
course.
hydrogen. I mean NaCl concentrated NaCl.
So, okay, now, Kaushik, you will write down the equation now. Come on, all of you write down the equation. See whether you are comfortable. NaCl plus H2O. You also write NaCl plus H2O. Okay, on electrolysis, what will happen? You know what is the product.
HCl.
Sodium hydroxide has to come. Sodium hydroxide has to come. Chlorine has to come. And hydrogen has to come.
It is among gas, right?
Yes.
I'm reading that.
Okay. We do it.
So ma'am, H2 will evaporate.
Not evaporate, it's a gas which
H2
is
ऊपर जाएगा.
वही वाला sign है.
upward.
Upward side.
Upward, or you can also put a G. You can also put a G, that's all.
So ma'am, NaCl plus H2 gives you NaOH plus Cl2 plus H2 and that
And balance the equation. Not to balance and have not balanced.
Na2.
Cl2.
Chlorine is a gas, hydrogen is a gas. If you balance it now, you will get 2 sodium chloride. If you are taking 2 sodium chloride, then you will get 2 sodium hydroxide. If you are getting 2 hydroxide, then obviously 2 water.
ये भी 2 NaOH है और ये भी 2 H2.
Size of the compound.
तो जो इसके अंदर H2 बोला.
Gives you 2.
Why do you
H2.
Then those 3 things are important now. They are talking about what are the compounds. You have bleaching powder, you will have baking soda, washing soda, and your last thing is POP.
Ma'am, PSA is not coming.
Why it is not?
अरे
मैम आपने मना कर दिया
And also the last one, which is water of displacement.
Ma'am, these guys have it so easy.
नहीं आ रहा right
अच्छा ठीक है
Actually, ultimately, what did I tell you? Whatever you're learning, where are you going to keep it? You're going to keep it for your
board exams.
Then don't be happy about it, right? Think that you have to learn.
That's right.
Aja. Reflection table क्या है?
Like the diagrams and
मैम रिफ्रैक्शन का डायग्राम तो रिफ्लेक्शन जैसे ही आपको ऐसे
refraction के diagram refraction जैसे ही है.
नहीं तो यार
Wow.
अच्छा, by the way, did you do your test paper?
Yes.
Then how much did you get?
हम दैट ये
हाँ, इसीलिए.
The first chapter, right?
हाँ,
I got
right.
9 and diagram 15.
मेरे को भी आसपास ही मिला था
हाँ,
90 दिन
Yeah,
लगा
yeah,
इससे ज्यादा मिला था
yeah, I've seen it.
And then
Come to chapter number 9. Reflection. See, even this chapter, how will you read? Don't read it at a stretch. Certain things that we must remember is that. Okay. Split it up into two. You don't want, you can split. Okay, there are two things that you have to remember. One is lens separating UV and your glass reflection. Okay, as mirrors, that part of it UV separate.
and the
मेरा
lens
volume
and the
नहीं
mirrors,
वॉल्यूम नहीं
like
वो कर
the lens and the mirror is understandable, but then this glass stuff and I don't get.
कितनी बार हम यहाँ पे रहे? You know, now I am giving you that idea. क्या हुआ? What is so difficult about it?
Like after it refracts and then
You have here this diagram itself is not.
I know. Even in the exam, I do this correctly. Then after that, I didn't mark it correctly, and then I lost marks in this. And then it asked me like,
You get me your scale. I'll show you why this diagram.
it should be like here
It should,
from
it
here.
should come closer to the
Closer
mark.
to the-
No. You can do the same thing again. You do it. Now try to do it and see whether it is not correct.
हम can you tell how to learn the diagram
Six diagrams, 6 ray diagrams.
Yes, ma'am.
to be by her day.
8
You learn it.
Ma'am, diagrams are easy to remember, but then this refraction, I still don't get it.
You do it right now. You do it now. You
One
find this time.
lens,
You do it.
one
You do the do the mirrors first. Okay.
And then
6 diagrams for the mirrors. What happens in reflection? Okay. Ray of light. It's coming back to the same media. That is why it is reflection. And always remember to put the shadow. Draw that line. Otherwise, teachers will give you wrong. Whereas if you don't listen to me, you will miss out many points. I'm just revising it only for your sake. Okay, you're asking me how to draw the diagram, so you listen, better listen. So we have got 6 diagrams. What is the first one? What should we remember? Is whenever you're talking about it, suppose I'm drawing the mirror. Suppose I'm taking a concave mirror. We have got P, we have got F, and we have got a C. 6 diagrams, very easy to remember. First diagram, the object is at infinity. Second, it's coming
Beyond
closer.
C.
So it is coming beyond C.
And
Third
C.
is will come at C. Fourth is
Between
between
C
C
and
and F. Yeah. Next
And
will be
F.
at F.
And between F and B.
Must be, yeah.
And those are easy to remember.
Then, once you understand why those 6 positions are, what is the first thing in all the 6 of them? You will find that the first ray is going to be a constant. Whether the object is here, the first ray is always the incident ray. In all the 6 of them, if you notice. Okay. Second thing, what do we know? What happens after reflection? It has to come through C, through F. So it has to come through F. Except for the last one, sixth one, because it's a virtual one.
image.
Okay, you have to extend the dotted line behind the mirror. So in plus 5, that is the first 5, this is very easy to remember. And the second ray can be either going through F, again it is coming back, whatever it is. And the first ray is always going to be the incident ray after reflection passes through F. Second one, it is passing through F, after reflection it becomes parallel.
The images from that.
Do each one very carefully, it is very easy.
So, in this
Ma'am,
time,
for
where is the
refraction.
image form?
And C is always at C.
Concave convex क्या है?
But it is object please.
Which one? This is your object. This is A, B is your object. If I draw it accurately, I don't have a scale here. This has to be very accurate. Okay, passing through F, and you're taking another one passing through F and cutting it. You will find that this is going to be exactly here. This is how it will be. That is the only position. Sometimes in the sum also they will tell you. Okay, object is placed at C. What is the image distance? There is no need for you to do any calculation because at C, that is the only position where you will have your object and image at the same position. Okay, so this is one trick that you have to remember. Just to confuse you, they'll give you focal length and all that. Is that okay? Now you see the diagrams and see whether it is easy or not.
Mom, reflection I like learn, but for refract.
ये हो गया आपका concave. This is your pole. Okay. Suppose this is C. Where will F come? Exactly half. It's going to be exactly half of it. Okay. So I'm having your object which is here. This is an incident ray. After reflection, it's coming back to F. Second ray, I'm talking about another ray passing through F, and it becomes parallel to the principal axis. Now, if you use your scale very accurately, you will find that the image is formed here. I'm not using the scale as well. This is how it is going to go.
And what would be the nature of it?
Real and inverted, and position will be at C. Okay?
And the size.
Same size, same thing. This is 1 centimeter. This will also be 1 centimeter. So it is inverted, same size as that of the object, and it is real.
I have a doubt
In
electricity.
okay,
It's a numerical.
what is it?
In this one.
Ah,
So in this one, A
what are they asking? Calculate the effective resistance between point A and B. Chalo, bolo.
is where AC and CB are in series. That means 5 volt is parallel to 1. But here, how these two are in series, they can't be series.
It is.
How? But
No.
like,
Okay, let me just draw this. Okay, now let us see this. I've given you one example which is exactly similar to this. You were there? I'm sure you were there. I'm giving you a diagram like this. Just take it down, everyone. Take it down, everyone. Boys, you asked you are doing it. Yeah. So I've got A, B, calculate. The question is calculate the effective resistance.
Ma'am, we did this. We did this.
I remember I've done this.
ये question
Between points A and B.
test में भी आया।
Shayad. But
Ma'am, this
I
question given on UT
test
test also.
also.
Now, between A and B, right? That means here and here. Subject? That means the current is passing from here. Current will go here and here and here. It is splitting up. Here. This one and the current is coming here. That means 3 and 2 are in series. Okay? Another branch, we have got only one, so there's no problem. There's a third branch, just like water. So the current is going here and it is coming here. It is going like this and like this. That means 3 and 2 is also in series.
Ma'am, so every
Subject?
current is like colliding with each other at point B.
So we have got it splitting up. It is going in 3 branches. Again, it is coming back. So what is happening now? Again, 3 and 2. These two will be in series. Now what is in 3 and 2? So you have got 3 and 2 here. We have got 1 here. And we have got 3 and 2 here. That makes it 5. That means these 3 are once again in parallel. Is that okay?
Yes, ma'am.
Now you can use your 1 upon R.
We have not started with this one.
ये तो finish भी हो गया हमारा ये।
We didn't even start. We are still at human.
ठीक है ठीक है।
हम लोग के ह्यूमन है नहीं हुआ हमारे में प्रेरणा
हमको ही पढ़ा रही है हमारा रिसर्च में साइन कन्वेंशन शुरू करवाया है
हाँ
एग्जाम में फिर कैसे दिया
और
How can three
Sign
resistance,
convention नहीं
3,
example.
2, 3 and 6 be
Speed
connected to the
one
total
है।
resistance of 4 and
पीटी
Next
वन
question.
का साइन कन्वेंशन का
textbook question है देखो। And then-
पीटी वन का साइन
मिरर का lenses का शुरू किया साइन
See, obviously now you have to use one in series and one in parallel. Okay, suppose you want it as 4 total resistance, okay? 2, 3 and 6. If you club it up together, you will definitely not come. Okay, so you keep 2 separately, 3 and 6 you make it as parallel. You will get some answer that you add it to 2 and see what is the combination. Understood? You do 3 and 6. You can do this way. One is in series and the other 2 you keep it in parallel. Suppose you keep 3 and 6 here and then add it up to 2. Okay, different combinations you will write, you will get the answer that is required. What are the questions? All sums only, no?
Yeah.
3 minutes. Let me just tell you, I think there is this sound. Yeah. Resistivity. See there, only page number 188. The next question, question number 4. Yeah, as soon as I saw that, I told you we have done it because it's given in your text. Okay, boys, do you remember about resistivity?
हाँ resistivity series ना
Huh?
next also
Oh, my.
वो resistivity
Oh, row.
Rho.
Yes, ma'am. I remember it.
Okay.
Perfect.
और
We talk about resistance first.
yes
Okay, resistance is depending on 2 things.
The area
Area
and length.
If the length is more, what will happen to resistance?
It will
will
decrease.
Directly proportional.
Yes,
Okay. It is directly proportional to area, and it is inversely proportional to
The
area.
area.
If the area becomes smaller and smaller, obviously the
Resistance
resistance will be more. R is capital R is resistance, not resistivity. So if I combine these two, we are getting this. So in order to remove this sign of proportionality, we are putting a constant, and that happens to be your resistivity. So rho L upon A. Suppose I want to find out what is this rho, I am going to rearrange this. So A will come here, R A, R times A, L will come here upon it, R A upon it. So that is your resistivity.
Resistance into ampere.
तो अभी SI unit क्या होगा इसका?
Ohm. नहीं.
What is R?
Resistance.
Resistance. Unit of resistance will be what?
Ohm.
Ohm.
Meter square.
Area. What is the unit of area? Meter square.
square.
Okay, something
Meter square.
Meter square. Length will be measured in
Ohm meter.
meter.
Ohm meter.
So,
Ohm meter.
so SI unit of resistivity will be ohm meter. So, okay, and this is specific. That means what it depends upon the material. You see the table there? It depends on what is the silver, copper, whatever it is. It does not depend upon the length or area. Okay, it ultimately depends upon the substance that you have taken. Is that okay? Anything is entering or no? Or you say it's not there for my school exam, now I am not accepted.
No one entering.
ऐसा ही है ना?
नहीं entering अरे मतलब
Who is lost in the pot?
चुप
Anything else? If you are absent for some, you were absent for quite some time. Everything is okay. 2, 3 weeks, I think you were absent. 1 week. More than a week. 2 cases. Even this chapter on electricity. Whereas if you have, listen, electricity, don't read it as a full chapter. Break it up into smaller sections. First is definition of what is current, Ohm's law, resistance, resistivity, both separately. Second thing is afterwards you are talking about difference between resistance, resistivity. Go in the same order of what I have taught you also. I have also taught you in a particular way. Then you read about parallel and series, combination yoga. Okay. Afterwards, the second part of it is your heating effect, Joule's law, power. That will be the second part.
And the numericals.
Numericals will be always there. Numericals only in 2 chapters. Light wala chapter and electricity. Nothing much.
Now numericals is not available. No. And I'm having trouble solving.
In light, say what formula do you have? Lens के लिए एक formula है, mirror के लिए एक formula है. That's all. And one power. P is equal to 1 upon it. That's all. Why you will have trouble if you are not very particular about your practice?
Leving right hand and the left hand. Leving is left hand and the right is right.
Thumb rule.
Leverage is right hand.
It is a thumb rule.
Right hand thumb rule.
Fleming right hand नहीं है.
Left
Fleming is left.
That's right. Left.
I told you, please remove all cards.
It is actually a right hand. Oh boys, listen. There's a right hand Fleming rule also. Luckily, it's not there.
It is not there. It is not there.
Yeah, as I
The earlier books, no, yeah.
Our teacher used to do some big periodic table and one of the things we said was so it created a problem for students.
That's what I'm saying. No, it's ridiculous. NCERT will not have allowed it. Without a periodic table, you will not understand. Bye. Take care.
I
Don't forget to give me those marks that you can just write it down.
Yes.
Next class we don't have you say, Friday's class is not there, no?
Yes, ma'am.
You are a Friday class.
For sure.
Kaushik, should I go or there shall be rounds?
Look now, I advise you.
I'll earn tactics. Message me.
Acid basis because you see like I want to clear it out as soon as possible because मुझे कुछ नहीं करना
Got it.
क्या
You know तो चलेगा.
देखो का I think I get it.
हमें आ रहा है 60 marks आ रहा है.
तेरा क्या है 60 marks
Thank you for your water today. I owe you this water.
अभी तो एग्जाम
I'll give you water like
एक लीटर नहीं क्या पूरा
चलेगा.
हाँ ठीक है
Thanks.
Right.
चलेगा. पानी कभी भी बना नहीं करती. बता. I'm very kind.
That's what you said.
Fee बनाया.
Fee?
It's fine. मेरे को पता है वो fine. I'm not dumb.
Sounds like fee.
You are saying. मैं
Oh,
fee बोल रही हूँ.
girls, boys.
कैसे बनाते हैं?
अच्छा.
Let's यही करते हैं.
Look.